In this session, we are going to discuss about the isometric projections of regular planes, that is square, circle, pentagon, hexagon, and other polygons. So first, we'll go with the projection of circle. Isometric projections of regular planes. First, we'll go with the square of around 50 mm. 50 mm has a side. Then we'll go with the circle. Okay, let's start with the projection of normal square. For any of the isometric objects or else direct isometric figure questions, first we have to draw the orthographic projection of that object onto the plane sheet. Then we'll go for isometric projections. In coming sessions, you can know why it is necessary to draw the isometric projections or else orthographic projections for any of the isometric figures that comes from your orthographic. Right, this is a normal square of side 50 and A, B, C, D. I can consider this as a top view or else front view. If I consider this as a top view, then the front view should be like this. Means our regular square is lying on the HP. So HP rotates clockwise 90 degrees and your front view falls on the XY. So this is X and Y, right? The reference line of the principal planes. And coming here A dash, D dash, B dash and C dash, right? This is one way of solving the problems. If your square prism, suppose assume this protractor has a square plane that is lying on the HP, the front view that falls on XY. So I have to draw this in isometric view. So as we know that in top view, this is length, 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 and this is width. Coming to isometric, we have to draw the 120 degrees line, right? I'm making 30 degrees. In this manner. And in this manner, right? This will be the height. But we are dealing with the planes, we don't require any height because the height of this plane is in this position, it is 0. If this is the front view and this is the top view, this would be coming reverse. So we have to consider in front view we can see the length and height, but now it is falling on HP, length and width would be considered. So this would be the length, this would be the width, and there is no height because the dimension, the thickness of the plane is 0. So now we have to place this square over here in this position. So this is length. So length falls over here, this line. Width, this width falls on this line. So I'll take this B has the reference point O and I'll place it over here. So this point is B. Why I'm taking the capital letter here and why I'm taking the small letters here? That means this is the original figure and this is the projection. So always projection should be represented with the small letters and the original figure should be represented with the capital letters. So I can take this one like this, and with the regular compass or scale you can measure this dimension. You can measure this dimension and you can place it over here, or else we'll follow the compass. That would be flexible for all the methods. So I have taken 50 from here, 50, that is A, that is A, and from B I can measure C. So from here C, and from C I can measure D. So from C I can measure D. This is C. So from A I can measure D. This point is D. So now can I join this A, B, C, D? You can see the small comparison between this. All the lengths are same over here. The AB is same as this, BC is same, AD is same, and your CD is also same here. But the angle over here, the 90 degrees, and the diagonals, these two diagonals are different in isometric. This is the orthographic 90 degrees view of any of the object. If your object is like this, the object is like this, we have to see 90 degrees in this direction. So we can draw the semicircle. But when you look this object in this angle, you can't see the all the dimensions. You can't see the all true dimensions here. That would be your eyes orthographic in this way or in this way. But the angles would be different over here. So now can we join this? So this is the isometric projection of a square plane that is resting on HP. If I take this plane perpendicular to HP, means our plane is lying on VP. So this plane would be in standing position. This would be your front view. This would be your top view. So top view is a line, front view is a square. I'll draw that over here. And here I have to consider height, because in front view we can see the height and length, right? We can't see the width. So I'm considering this has length, this has width. Similar over here, length, width, and this is height. Okay, I'm drawing the figure over here in the same manner. So I have marked this. This would be B, this would be A, this would be C, this would be D. So now can I join this? And here you can see one thing, the CD would be always parallel to AB. means length axis. These are called length axis. These are called length axis, and these lines are called isometric lines. These are isometric axis, length, width, height, and the parallel lines is called isometric lines. AB is always parallel to CD. BC is always parallel to AD. Here also you can see the AB is always parallel to DC. BC is always parallel to AD. So this comes your front view. This comes your front view. Means the projection of this would be like this. A dash, B dash, C dash, D dash, and falling to this projector D comma A, C comma B. This would be the orthographic projection of this square in this position. And for this position, in the lying position, this would be the orthographic projection. If you want to draw the orthographic isometric projection of this square plane in this position, you have to draw first this, then we have to go for this. For saving time, I have compared this same over here. Right.